Okay, we're going to be doing operations with integers. The first point I wanted to make is, well, what is an integer? Integers are just whole numbers and their opposites. So we have 1 and -1, and 2 and -2, 3, -3, so on and so on and so on forever. No fractions, no decimals, just whole numbers and their opposites. I think maybe 0 is actually counted as one of the integers too. Okay. So let's start with adding integers. First we're going to be doing some modeling with integers using some counters and then the number line. And then on the next page we're going to be talking about the actual rules that we apply. So we'll start with 4 plus -9. For the purposes of this exercise, I'm going to let the yellow be my positive, and I'm going to let the red be my negative numbers. So with the first one, and let me get them. I'm going to use 4 plus -9. So for my 4, 1, 2, 3, 4, there's my positive 4. For my negatives, I'm going to say, okay, I've got -1, 2, 3, 4, 5, 6, 7, 8, 9. Should have used a smaller number there. Okay. So this is modeling. What happens here whenever you use these counter chips to model these is you end up with what's called zero pairs. If you have a positive one and a negative one right here, well, those guys just cancel each other out. And these, and these, and these. And what ultimately happens is whatever's left over, whether they're positive or negative, reveals the answer to you. In this case, I have 1, 2, 3, 4, 5 negatives left over. My answer to this problem, and let me just go ahead and put it over here with this guy. My answer to this problem equals, and again, we said we have 5 negatives left over here, -5. So that's how it's modeled with counters. You line them up, find all the positives that can connect with the negative, mark them out as zero pairs. Whatever's left over reveals the answer. Let's try that again with -4 plus -3. I'm going to bring out my counters. I'm going to start with my -3 here, so -1, 2, 3, and I also have -4. 1, 2, 3, 4. Now this scenario is a little different. Before we were going to be marking out zero pairs, a positive and a negative, but I don't have any positives over here, they're just all negatives. So I have no zero pairs. In order to get my answer, I have to keep all of these guys. 1, 2, 3, 4, 5, 6, 7. My answer to this one equals, and again it's 7 negatives, so my answer is -7. When the signs are the same, you just use all of those same counters and then keep them all for your answer. No zero pairs. Let's look at the modeling on the number line. On the number line, we've got I'm going to start here. I've got 4 plus -9. So my first arrow is going to go from 0 to my first number, which in this case is 4. My second number is going to go from that 4, -9. A -9 direction will move me back in this direction, but I have to start where that one ended right there. So I'm going to go to where that 4, and I'm going to go backwards 9 spaces. That's 4 spaces. 5, 6, 7, 8, 9. Looks like it'll put me right there above that -5, and so I'm just going to show that ends right there. And so that actually gave me the same answer as whenever I had all my positive and negative counters out here. I got to -5 there. This is how we show it on the number line. 4 plus -9 is -5. And we can also show that with the next one here. I've got -3 plus -4. I'm still starting at 0, and I'm still going to the first number, -3. And now I go from that number, my -3, another -4. So again, from the -3, 1, 2, 3, 4. And I can show that answer also equaling -7. So that's how it looks with the modeling. Let's see how it looks with the rules. And these are just the real basic rules how to do this. When the signs are the same, like they're both negative or they're both positive, you just add and keep the sign. Seems simple enough. 15 plus 6, that's 15, 16, 17, 18, 19, 20, 21. So I added and keep the sign. In this case, my signs are negative, so it's a -21. The signs are the same, I added them and kept the sign. We've been doing this with positive numbers for a long time. My signs are the same, they're both positive, so I add them and keep the sign. Just keep my answer positive. Now when the signs are different, like one being negative and one being positive, I have to subtract. Whereas over here I was adding, my signs are different, I'm going to subtract. And keep the sign of the integer with the greater absolute value. Okay, so let's start by subtracting these guys. I'm going to do, and it's always just going to be the bigger number minus the smaller number, no matter what's positive or negative. 12 minus 7, well, I'm just going to count up from 7 to do that. 7, 8, 9, 10, 11, 12, so that'll get me 5. So I've subtracted them. 12 minus 7 is 5. And I'm going to keep the sign of the integer with the greater absolute value. Now absolute value is just distance from 0. The number here that has the greater distance from 0 is my -12. This is 12 spaces from 0, whereas this is 7 spaces from 0. So since this is my greater absolute value, that's the sign of my answer. Let's do that again. 8 minus 3, well 3, 4, 5, 6, 7, 8, that's going to be 5 again. In this scenario, my positive number is farther from 0. So my answer will be positive. There's more positives here than negatives. My answer is positive. Next, we're going to be talking about subtracting integers. Subtracting integers is much the same as adding integers, because what we're going to be doing is we're actually going to be changing the subtracting into adding. And there's a couple of different sayings I've heard associated with this. One of them is add a line, change the sign. And the other one is keep, change, switch. You're doing the same thing in both of these. And let's just see how that works. In this one right here, -4 minus 6, again, I'm just going to be changing this into an adding integers problem. So whenever they say add a line, change the sign, -4 minus 6, the way that we do that is add a line, change the sign. It's always add a line to the subtraction to make it positive, change the sign of the second number. Let's see how that looks with the second one. We've got 2 minus -7, so we add a line, change the sign. That changes both of these subtracting integers problem into adding integers problems. We have -4 plus -6. On this one we have 2 plus 7. 2 plus 7 we've done for a long time. I can see that's 9. Here my signs are the same. And when the signs are the same, I'm going to add them and keep the sign. So I'm going to add them. 4 plus 6 is 10 and keep the sign. -10. and this one was 9. So once we change them to adding integer problems from subtracting integer problems, I'm just applying the same rule that we learned over here. Let's look at it and think of it in terms of keep, change, switch. I'm going to keep my first number, -4, change the subtract to plus, and change my 6 to -6. Again, keep the first number, change it to plus, change it to a +7. This will be 2 plus 7. So add a line, change the sign, keep, change, switch, however you like to think about it. We're just changing subtracting integer problems to adding integer problems. And our modeling becomes the same. I've got -4 plus -6. And again, that's just a movement from 0 to the first number, and then from that number, what was it, 6, -6, in a -6 direction. So 1, 2, 3, 4, 5, 6 gives me my answer right here, -10. And the last thing we're going to look at is multiplying and dividing integers. Down here I've got the mystic triangle, and we're going to see how this applies to multiplying and dividing integers. We're multiplying and dividing just like we always have. We're doing 25 divided by 5. In this case it is a -5, but 25 divided by 5, I know that if I count 5, 10, 15, 20, 25, that 5 will go into this 25 5 times. So my answer is 5. The question is, when I have these negatives in here, is my answer positive or negative when multiplying and dividing? Well, the mystic triangle is how we know. Usually what I do is I have my students make this triangle on their paper with the little plus, minus, and minus. And what I do is, since this problem has a positive here and a negative here, I just have them cover up with their hand, but I'll just do it by marking through it up here. I'll have them cover up the positive and the negative with their hand. So they'll just cover this part of the triangle over here, and this is what's left over. My answer here is -5, because I had a positive and a negative. When I cover those up, shows me my answer. Let's look at the next one. I've got a -7 times 4. Well, I know that 7 times 4 is 28. But again, I'm going to cover up a negative and a positive. Cover up, let me change my color here. Cover up a negative and a positive, so I know my answer is negative. -28. Let's see what it looks like whenever I have a negative and a negative. Well, I know 8 divided by 2, 2, 4, 6, 8, it'll go into it 4 times. On this one, I'm going to be covering up, since both of them are a negative here and a negative here, since both of them are a negative, I would have them just cover up the bottom of the triangle there. My answer is positive. And -8 divided by -2 is a +4.